All right, so we're going to start talking about conditional probability, which means we're going to be dealing with the probability of something happening given that another thing has already happened. So we're going to start with the notation for that. So that's going to look like this, the probability of A given B. So it wouldn't be a bad idea to define that here. So in this situation where we have a set A and a set B, this would be the probability of event A taking place given that B has already taken place. Okay, so we're no longer just talking about the probability of event A out of the whole set. Now we're talking about it within subgroups of this set. So I'll explain what that means with this example of a table here. So what we've got in this table is records of the primary modes of transportation for the population of 3 major cities. So we've got New York, Los Angeles, Chicago, and what we have is the percentage of that population that chooses to use cars, trains, or walk as their primary method of transportation. All right, so a couple things we'll notice is that in this whole study, if the whole study is 100% of our population, 25% of that population came from Chicago, 35% came from LA, 40% came from New York, and we could also break it down by car, train, and walk. So if I include everybody from all of these cities, 31% of the population chose car, 51% of the population chose train, and 18% chose to walk. So this is the whole population here. If I add up all of these, I should get 100%. So a real-world type situation here might be that these civil engineers are trying to make determinations about how to support public transportation. Is a person more likely to prefer cars if they live in New York or if they live in Los Angeles? So what we're not asking here, and I don't want you to write this down, what we're not asking is what is the probability of someone driving in a car. That's not what we're asking, because that's taking into account every single city, right? I'm not talking about every city. I want to know what the probability of them preferring a car is if they live specifically in these 2 cities. So I'm not going out of this whole population anymore. I'm choosing from these 2 subgroups. So just this one time in words, I think it would be helpful to write out what this is actually asking in words. So what we're trying to do here is to compare these 2 probabilities. The probability of preferring cars given that a person lives in New York. Okay, so that's the first thing. What's the probability that someone prefers a car given that they already live in New York? And then the same exact scenario, but given that they live in Los Angeles. Okay, so we're going to have to make determinations about each of these probabilities. I'm going to use blue, and I'm just going to highlight that statement about New York, and we're going to do some work that focuses on that specific probability. And I'm going to use, I don't want to use green, I'm going to use purple on Los Angeles. So anytime we're working on Los Angeles, I'll use the purple pen moving forward here. Okay, so I'm not trying to figure out just the probability of using cars in general, right? That's not what I'm doing. What I'm going to want to do is compare the probability of preferring cars given that they live in New York. So that's going to be this statement. The probability of someone choosing a car given, right, just like the notation we see up here, given that they live in New York. We're going to need to calculate that probability. And the other probability we're going to need here is we're going to need the probability of someone choosing a car given that they live in Los Angeles. So let's work with that. If I want to find the probability of someone choosing a car given that they live in New York, I'm only choosing from the people in New York. So my denominator shouldn't be 100% anymore. It shouldn't be 1. It's going to be only the people who live in New York. So who are the people that live in New York? Well, these are all the people that live in New York. So my denominator then is going to be that 0.40, because those are the people in this study who live in New York. Now, of those 0.4 people, how many of them prefer cars? This many, 0.05. So then this probability, this conditional probability, is 0.05 over 0.4, and our graphing calculator would reduce that fraction to exactly 1/8. I'm not going to box it yet because that's not really our answer. That's just evidence that points us towards our answer. Let's do the same thing over here with Los Angeles. We're going to calculate the probability of someone preferring a car given that they live in Los Angeles. So where are all the people that live in Los Angeles? This is the number of people in our study that live in Los Angeles. So of those people, how many of them also prefer cars? This many. 0.18. So 0.18, which does not reduce, so we have 18/35. Okay, so we've done the math here, and what I'd like to do, since it's not asking us for the exact probability here, we're just using this to support our argument, I'm going to turn these into percents just so that I can see a little bit better what these numbers actually mean. If you find out what 1/8 is as a percent, it's approximately 13%. And 18/35 is approximately 51%. So now it should be a little bit clearer. Where is it more likely that someone is going to prefer a car? Well, in New York, someone in New York has a 13% chance of preferring a car, and in Los Angeles, people have a 51% chance of preferring a car. So therefore, people are more likely to prefer a car in Los Angeles. And I would write out, people are more likely to prefer the car in Los Angeles. Okay, so what did we just figure out? We figured out a little formula that will help us find the conditional probability of any situation, regardless of what the two subsets are. So let's have our formula, our conditional probability formula. Right here. Okay. In the future, if I ever want to find out the probability of A given B, well, what do I need to do? Let's take a look at the example we just did. When I wanted to find out the probability of C given New York, I took the probability of someone just being in New York in general for my denominator. So I'm going to take this second part, and that will be my denominator. So in our formula, our denominator here is going to be the probability of B. Now our numerator is a little bit different, because where did I get this number from? Well, that was the people who are both car people and are New York people. This intersection, this. Okay, so our numerator then is going to be the probability of A intersection B. And this is the process that we just followed with the example about the cars in New York and LA, but we could apply it to any situation where we have two sets and we're asking for the probability of one thing given another thing. So the big takeaway here is this formula, and we're going to play around with it a lot in class. When we get to class on Monday, we're going to make a real-world example using people in the room who have siblings and drive cars and things like that, and we'll try to calculate some of these given probabilities just using this formula over and over again.